Here's section 1.5, right triangle trigonometry. Let's go over the following definitions. So you can just read them, but basically this is what you need to know. These definitions are basically going to help you find angle measurements. And another thing that you should also just remember that inverse functions have restrictions. And the reason why we have restrictions is because we want relations or rules to behave like a function. Okay, that's all you need to know from about this slide. And in a future section, we're going to be going more in depth when it comes to working with inverse trig functions. Let's go to the next slide. So here's number one. It says evaluate each expression using a calculator. Give the result in degrees to the nearest tenth. Something that is very important. You want to make sure that your calculator is in degrees for this problem. So just go to the mode and change it to degrees. And you just punch sine inverse of this ratio, and it's going to give you the following angle after you round to the nearest tenth. Something that will help you with working with the idea of inverse, is that every time that you work with an inverse trig function, remember that it's always going to give you back an angle. The answer is going to always be an angle. Let's go on to number 2. It says use a calculator to find the acute angle alpha to the nearest tenth of a degree that satisfy the equation. So for number 2, you need to find an angle that gives you 1.73, working with the trig function of tangent. So again, I'm looking for an angle, so I know I need to work with the inverse function of tangent. And let me just highlight what you saw on the previous slide, the definition of inverse tangent. So if I want to find the angle that generates 1.73, so I need to work with this. The angle is going to be generated by the tangent inverse of this x value, which is going to be 60 degrees once you round to the nearest tenth. And again, if you want me to, I can clarify this a little bit more in class. Let's go to the next slide. So on this slide, basically we are going to be reviewing what you saw in geometry. Let me read this. It says if alpha is an acute angle of a right triangle, then sine of alpha, here's your alpha, is the opposite side over the hypotenuse. Cosine of the alpha is the adjacent side over the hypotenuse. Tangent of the reference angle alpha is the opposite side over the adjacent side. And you should recognize the reciprocals here for cosecant, secant, and cotangent. And again, this is, like I said earlier, this is just review of geometry. And on section 1.4, we were working with the variables x, y, and r. So just to highlight that, here it is. And it has not changed. It still applies here. Sine of alpha in section 1.4 was the y value over the r. And in this section from geometry is the opposite over the hypotenuse. And you can see the other ones follow as well. Before I show you the next slide, whenever you're working with a right triangle, this is how we're going to be labeling the angles and the sides. Alpha, beta, the 90-degree angle. Opposite to the alpha is going to be lowercase a. Opposite to the angle beta is lowercase b, and opposite to the 90 degrees is letter C. Next slide. It says find the exact values of all 6 trigonometric functions for the angle alpha in the given right triangle. So the first thing we're going to be doing on problem number 3 is find the letter B, which is the side. You apply the Pythagorean theorem, and it should be review, and you end up with 2 radical 2. So that's B. Then I'm going to find all 6 trigonometric ratios of the angle alpha. So let's start with sine, the definition they used on the previous slide, opposite of hypotenuse. So the opposite side from the angle alpha is 1, the hypotenuse is 3. There's my answer. Cosine of alpha is adjacent over hypotenuse. Here's the adjacent, here's the hypotenuse. There's the answer. Tangent of alpha is the opposite side over the adjacent side, given this reference angle. You end up with this, but you rationalize, and this is your final answer. And cosecant is just the reciprocal of sine. Secant is the reciprocal of cosine. You rationalize. And tangent is the reciprocal of, cotangent is the reciprocal of tangent. And this is the answer. Now let me just add another problem here. 3.1. So now if I wanted to find sine of beta, so from here I need to apply the definition of sine, opposite of a hypotenuse, but now this is going to be my reference angle. Opposite to this reference angle now is 2 radical 2, and the hypotenuse has not changed, it's still 3. And if I want to find cosine of beta from this reference angle, the adjacent side over the hypotenuse, that's why you see this as the answer. And tangent of beta is the opposite side, 2 radical 2 over 1. So this is my answer. Let's go to number 4. It says solve each right triangle with the given sides and angles. In each case, make a sketch, route the round approximate answers to the nearest tenth. So they give you this information, and here's a picture that goes with it. But before I do that, you should recognize that this is the hypotenuse from the picture that you saw in an earlier slide here. So here's a picture. Here's my side A. Opposite to the side A is the angle alpha. Opposite to this letter C, the side C, is the 90 degree. So I'm able to find B using the Pythagorean theorem. So here's how you find B using the Pythagorean theorem. Now at this point, what we need to do is we're going to have to find the angles. And if you remember, as I mentioned earlier, the only way that you're going to be able to find angles is by using inverse functions. In this case, I am going to use the ratio sine of the angle alpha is opposite to the angle alpha is 10 and the hypotenuse is 12. That's why you see this here. I apply the inverse function and I end up with 56.4 degrees after I round. And then to find beta, all I need to do is I know that these two angles are complementary. So then I do the following and I end up with 33.6 degrees.